we'll be going through generics and collections for today's session. Okay, so this is what the concept what we are going to look into. So there is lot of predefined classes available for handling various data structures what we have come across. Okay, you guys would have already studied in data structure course, right? So now the thing is, we need not to implement each and everything from the scratch. So there is already predefined classes available which we can go for use it to implement those data structures. Okay, but only the thing is, what you need to have is a good understanding on which data type needs to be used and why it needs to be used or when it needs to be used. Okay, when we speak about various data structure, right? So conceptual knowledge is very important. Then we will be able to use this using the predefined classes. So what we'll do is we'll go for look into first one or two classes in detail, like how we can go for implement that, and the rest class I'll just give you overall view what is that, like when to use and all those things. So what do you mean by array list? So when we speak about the array list, so basically it is one of the class defined in Java package. Okay, so java.util.arraylist, so that comes under java.util package, and it inherits abstract class and it implements the list interface. So which means when we speak about a list, it's like going to be something similar to what we can say the list what we have used Python, right? So we'll just see, like start with the implementation of like how to create a list object and what all the methods available and when we are going to use those methods and what its advantage. So array list is initialized by giving a size. However, size is increased automatically of a collection grows or shrinks of objects. So which means this is a dynamic array list. So when we go for create an array, so array is going to be having a fixed size, but when you go for go create the array list, what happens is it is going to create the memory allocation for that dynamically. Okay, so and if it is going to reduce, it will also dynamically reduces the size. So this is how the array list has been designed. Now when we speak about like dealing with array list, so what we need to know is like the primitive data types, so such as int, char, float, right? So you can see int I small, so it's not a class, right? So it's a primitive data type. Character C small, so float. So this kind of primitive data type will not be able to create a array list. For that we can go for have a integer wrapper classes, and then we can go for create those array list. Okay, first I'll just show you certain examples, and then I'll just also start writing the code from the scratch, and we'll also go for look into the APIs before we get into this coding. So we can go for create any array list using a class name the array list. So if you want to go for use array list, we should be able to import that. So you might have seen in many places that like java.util.star, they would directly go for take it as star, which means all these things will be a part of that. So as suggested, please go ahead with taking a specific class whenever you wanted to deal with. The class array list, what you can see, so we can see that like it is going to inherit this object, abstract collection and abstract list, and it implements the below mentioned interfaces. These are all the interfaces what it is going to implement. Now what is important for us is one is constructor. You can see this constructor, right? So it has an empty constructor or a default constructor, and then you can send any collections into it. It will go for take any of the data type objects, and that's where like the generic, like we will be able to define what type of data it should be able to hold it. So as this array list concept is same, so we can go for create an array list of integer using an integer class, string, or any predefined classes. Okay, create an array list of user defined classes as well. So we are going to look both of the things. Okay, so now If you see here method, there is like a important method or most frequently used method will be add. So we'll keep adding the element. If you give the element, what it does, it will directly go for append the element at the end of the list. Or else we can also mention the given index, and then we'll go for pass the object which will be inserted into that particular index. We can also send like another like collection which we will be able to send, and it will add all the elements from that. When we speak about add all the element, what does that mean? It appends all the element into specified collection to the end of the list. We can also give the index if you don't want it to just append it. Okay, you can directly give the index so that it will insert all the elements in that given collection into that. And again, clear, clone, contains, and like again we can go with for each. Okay, so there is a for each method as well, so performs the given action for the each element of the iterable. So this will, whatever the operations you give, it will be ensure that it will be applied on each and every element, what we can say, element in the given array list. And get, if you want to get basically like in arrays we'll use a square bracket to get the element, right? So here we'll go for use a get method, and we can do a search operation kind of. So you can use index of and pass a object, it will search for that object whether it is available or not, and it will return the index if it is available, if not it will return -1. And before applying some logic we need to see, right? Say for example it could be an empty array list. In that case, if you want to do a insertion at some position or like any other operation, we should not give any exception. So it's always good to go with check whether it is a empty or not. Based on that we can take a call. So that is where this is empty method we can use. It will return true or false. Okay, and also there is one important concept what we need to understand here whenever it comes to any collections what we are going to deal with, right? So there is something called iterator. So basically it is a method iterator which is going to create a iterator object, so which we can be able to use it on like these collections to traversal. Traversal is one of the concept, right? We want to go through each and every element in the given collections, then we'll be able to do that. Okay, so we'll just start looking into this. I'll just go for create a new class, array list demo, and I'll include main method into it, right? So we'll go for create the array list object similar to any other. First we have to have a variable array list, and the variable name I'll give it as al, and then we'll have to create an object of array list. So when we want to create an object of an array list, we'll go with a new keyword followed by again class name, and then as we have seen the constructor, either we can give it as some like integer and we can go for create it, or else we can send certain values or like object and we'll be able to create. So for time being I'll create a array list of size 5. So you can see this here showing some error because we have to import that, and as I have not written in like Java import java.util.star, or like I have to give it as, I'll just go for include the specific array list. So we'll go for use this angular brackets to mention the data type. Okay, or give it as integer. I'll create an integer. So or else you can just take it and empty, like you need not to define any what size is required. It is going to create a by default array list. Okay, so this is how we are going to create the array list. You can go for add the number into that al dot, there is a method called add, so where we can keep adding the element. I'll just give it as 11. Okay, and similarly I'll go with add dot add 22. Let us just try to see whether we can go for add like al square bracket say index, I'll give it as now 0 1. I'll go for give it as index 2 equal to 33. Okay, so if you try to do this like an array, it will not allow. Always go with access it with the help of the methods what we have. Add. So once we have it, if you want to print it, right, so what we can do is system dot out dot println, and then let me just go for print it as al, and I'll go for save it, and I'll just go for run it. And you can see the output. The output what we are getting it as a list enclosed in between a square bracket, and separated, each and every element is separated by comma, right? So even in Python you would have seen the same way of like printing the list output. So this is how like how it is happening, because in ArrayList there is a, they have overridden the toString method, and they have iterated through each and every element. They have concatenated it into a single string which is enclosed in between a square bracket, and they are sending that string which has been written by that toString method, which has been overridden in ArrayList, is going to be just displayed by the our println method. See ArrayList API, and if you can see like add we have seen, right? So we can also just go for look how we can use this add all method. Okay, I'll just go for one more ArrayList. I'll name it as ArrayList2, and then I'll just go for add one single element into that, right? I'll go for add one single element into that, ArrayList2 dot add, and then I'll give it as say 44, right? And after that what I will do, okay, I'll just print this al2, and after that I'll go for add the previously created array list. Okay, previously created array list. So al2 dot add all. Okay, and I'll send this al, and I'll go for save it, right? And I'll go for display this ArrayList2 again, and I'll go for save it, and if I go for run it, see what you can see is this is the ArrayList1 which has 11, 22 and 33, right? And I have created a new array list which has 44, and then I have just add all the elements of ArrayList1 into ArrayList2, so you can see this like what's happening. And we can also go with array like add all. If you see here what we add all, we can give an index and again like the element what we need to add, right? So what I will do here, I can also like give the index. Index means now I have added one element 44, right? I'll give it as 0. I'll give the index as 0, and I'll just go for save it. See what happened, 11, 22, 33 has appeared or appended at the end as of now. And since I have given it as 0 and run, what happened is that 11, 22, 33 is appearing before 44, because it is inserting at the 0th index. It will push the element at the 0th index, and all the elements in the other collection what we have sent at as an input parameter for this add all method is going to be inserted at the given location. So which is better to use, arrays or array list? So Srinivas, it depends upon your problem statement. Okay, so which means like what kind of problem you're dealing with. If you have a fixed size, and if you have like some the operations where you need not to work on this insertion and all, like as of now we have seen, right? so we can like do the insertion at particular position. So that is all not possible like in array, so because it's like a fixed size. And when you go for create an array, if you want to do anything else, like you have to go for uh, create a new array, you have to transfer all the elements into that, and you have to do that manually. You have to write a method or a function to do that. Okay, but whereas here there is already predefined methods available which you can go for use it. We'll see whether we can create an array list without this type, giving like the different data types what we are going to handle specifically, right? So now I'll go for create array list arr equal to new array list. Okay, and then what I will do is I'll just go for add the values arr dot add, and then I'll just give it as 1, which is a string. Then I'll go for display that, save it and run it. Okay, sorry, I'm printing AL2, I have to print ARR. Run it again. You can see that it has one element. Now what I will do, I'll just try to add few more elements into this. Okay, I'll add it as 2. I will add it as 3, and I'll go for run it. So what you can observe here is, so when I go for add, this 1, 2 is string, another one is an integer, it is going to take it. Okay, so which means it is working something similar to what we have seen in Python list. Okay, so we can give any data like separated by comma, right? So something similar, which is what we can see here, right? So if you want to like having a specific, what we can say, data type of array list, then you can mention it in this angular bracket, and if you remove this, it is going to be a generic which will take any objects. Basically any objects, it will keep a sequence of like those object reference. And if you have given it this in angular bracket, what we can see, right? So that class name which we want to store exclusively, then it will go for ensure that it will have only integers. So since this ArrayList2 is an integer array list, if I go for insert, say for example ArrayList2 dot add of, I'll give it as hi, which is a string, and you can see it is like already giving a error. So string literal is not properly, okay, sorry, okay, this error is because of this. So if I see now this method add integer, so it is an integer array list where you cannot be able to add string. Okay, so it depends on like your your requirement. You can go for take or declare the array list and go for handle it. So now if you want to do any arithmetic operation on this, you should be able to go for get this, and based on the data types you will be able to just go for typecast it into that, and then you can go for use it. It depends as per the problem definition, or like as per your requirement. Okay, but this is how the array list how it works. And again, clear removes all the elements, clone returns a shallow copy of this array list. So what do you mean by this shallow copy? There are two copy, deep copy and shallow copy. So shallow copy means it will create a new array object, but all the elements in that is going to be copied as it is. Okay, and deep copy in the sense it will go for duplicate the all what we can say elements even inside that as well. Now uh, what if I just go for, see this array list what I have, right? So let me just go for add one more element, that's arr dot add, and I'll go for add array list what I have created. Okay, can I do this? So let me just go for run it. Yes, so the answer is right, we can do that. You can see that 1 2 3 which is an integer, and next object is what we can say array list. Now can you tell me what is the length of this arr now? If we want to check the length, so list, do we have a length attribute here? For look into what we can say the API as well to get to know what is available. So which means whenever you have come across what we can say anything what you wanted to see, like okay how we can do that, just try to go for refer this CL. It will be what we can say arranged in a alphabetical order or lexicographical order, right? So so length, we'll just see whether we have length, last index of last iterator, and L has been completed. Okay, but we can see that we have a method called size which returns the number of element in the list, and in array like we'll go for use it as length and all, right? So here we'll give it as size and just run. Okay, so it is 4. Can I do something like this here? How can I get the size of this particular object? So it's also like what we can say this array list having at the third index 0 1 2 3 we have this, right? If I want to get this, how can I do that? First we need to know how we can access each and every element in array list. So let me comment this for time being. Okay, so we have a method called get, right? And then we'll go for give it as like array index whatever we want, like 2 3. As of now I'll just give it as 3. Okay, so if I go for run this, the element in the third index has been written. Since I want to get the size, first I want to get the element dot get at index 3, and then we'll get its size. Okay, if I try to get this object, what we can see is we are getting this particular object, right? But if I try to put a size method for that, we are not able to get it. Why? Because whenever you do get method, okay, I'll just try to assign it to a variable and show you. Okay, so which means whenever we go for do this get method, it is going to return it as an object. So you want to get it as an array list, so like basically whenever we go for get it as an object, we should be able to again typecast it, and then you should be able to use it. So that is why when I tried to use this at the given index and again try to use the size, I was not able to get it because of that reason, because it returns an object. Just see one more important concept, that is iterator. Okay, so as I mentioned, like for any of this we will be able to go with creating the iterators. So what do you mean by that? Assuming that we have created a array list, okay, and it's of like say we wanted to store it as a string, so we'll go for add strings, right? So 3 strings has been added into this. Now you can see that there is a method called iterator what we have seen, right? And we have also understood that you see here, iterator method, there is a method called iterator which will return a iterator object, right? So that's why we have to create a iterator object. Since it is like array list of string, we can mention it as like string, so it is going to iterate over the string in the given array list. So what does this mean? So we'll be able to go for use this object, and we can just run through that instead of writing a for or for each loop, and we can go for do that. In iterator we have various predefined methods. You can see that iterator dot for each remaining, we have a variable which will get that element and it will go for print that. You can see that. So in a single line it is going taking it through each and every element in the given value, and it is going to display it. Or explore more about this iterate class a bit before we proceed. Iterator is an interface, so which means here we will have abstract methods available. Okay, so what are the methods? You can see there is for each remaining, so this is a method. Okay, and has next, so this is another method. Next, it will give like each and every element each and every time. If you call that iterator dot next, it will give the next element. Okay, so again, like remove the underlying collection from the last element returned. There's also a method called like has next. You can check a condition like whether it has a next element, then you can apply the logic on that. Next means it will return the next element. Okay, system dot out dot println, and then I'll take the iterator object dot, I'll give it as has next to check is there any next element which is available. Okay, run it, and you can see that it is saying it as false. Okay, so now I'll place the same thing. Even though we have 3 element in that what we can say array list, it is saying it as has next, no. But if I place the same thing before this for each remaining, okay, I'll save it and run it, proceed. You can see that it is saying true before like we start the iterator, but once it reach the end, it is saying it as false. You can say once you get a iterator object, and if it has reached the end, it will say it as like it is not available, so there is no element in that. Just go for create one more object. Okay, I'll name it as iterator2, and then what I will do, I'll just write a normal loop for int I equal to 0, I is less than array list dot, I want to get the size of that dot size, so it will give me the size, and then I plus plus. Okay, do is I'll just go for print it using a normal, so that is iterator1, it's a new iterator. Okay, iterator1 dot next, one dot next. I'll go for save it, and I'll just run it, and you can see that, see, every time it is going to take one element and print it. Okay, it will go for take another element and print it. If I don't go with this for loop, we can just write a logic. Just I'll go for, if I do this and run, since I have done only once, it will go for print only one element A, and if I go for give it twice, it will go for take the next element and print it. What you can see here is there is no for loop, but still in this, using this method again and again, I can go through each and every element of that given things. Okay, so last time I used a for loop so that like it will run those number of times, or else if you want to go with specific time based on a condition only, you can visit the next element. In that situations, this iterator is going to play a very helpful role. Okay, right. So now we have seen one collection, that is ArrayList, in like kind of broader way. So same way there are various other things. Okay, so there is linked list. So when we speak about linked list, it is something similar to the array list itself, but only thing is there is a slight difference in between the how memory allocation happens, and like we can implement the linked list data structure. Okay, and when we speak about the linked list, what they have implemented is a double linked list. So what do you mean by double linked list? This is the element what we have. Okay, the first node index is like, again you can see left hand side it is null, and the right side, it like in right node it will have a the first node index. Okay, again first node will have the previous and the next, both index will be stored. Okay, assuming that like if this node is at say 1000, and the second node is at say 2000, this 2000 will be stored here, that is the next node, and this third node is at 3000, just like for understanding this 4000, and this 3000 will be stored here, and this 1000 is the previous node, right? So that 1000 is going to be the reference of that object is going to be stored. So here it is going to store the previous object is 2000, and the next object is 4000, and the previous object is 3000, and the next object is null, means there is no object. There is the end of the double linked list. Okay, so again there is a circular linked list concept as well, right? But this is not a circular, where like it is a double linked list which we'll have. Now when we try to compare over the array list and this, like again, so it will also having add and all the various methods what we have in array list. But what happens in array list, when you create a array list of size 5, say it will go for create a array list of size so what we can say 5. Okay, so which start from say 0th index, 1 2 3 and 4. But the moment when we go for add, like say first element, say 1 2 3 4 5, and if you go for add a sixth element, the same array list dot add 6, then it will go for like enlarge the size. Okay, so when I say enlarge the size from this array list, like what we had it from 5, it will go for get it into like say maybe 10 elements. Even though like we might not go for use all those things, it will go for use 10 elements. Okay, so then it will store like 1 2 3 4 5 6th element, but like that extra space is going to get created, right? So that's what is going to happen. But whereas in this linked list, what happens, it will go for create only one element, one node, and it will add the data. It will do the insertion, means it will go for create only one node and insert that into specific position. So that's how the linked list what we have is going to work. Okay, so that's the difference between the array list and the linked list what we have. So when we speak about linked list, we have adding elements, updating elements, remove elements, iterating over the elements. We can, so the iterator what we have seen, like we will be able to use this iterator to iterate over the linked list element as so. Like we can also convert that into array. So there's a method to convert into array. We can check the size. So we have see this class details and all those things, right? So again we have added the index, something similar what we have seen in the previous, right? Add all like this, where we can give the index. Add first means you can add at the first, add last means you can add at the last, clear means it will remove all the element, clone it will do the copy of that. Okay, contains, it will return whether it is search operation basically, right? So descending iterators, it will traverse through the element in that linked list in a reverse way. And get, you can give the index and you can get the element. get first, get last will get the first and last element. Index of it will you can do a search operation using this index of as index of. It will search for that particular occurrence. If it is available, it will return the index, or else it will return -1. Okay. And list iterators returns a list iterator, which will go for like iterate through each and every element from the first to the last. Okay. And you can also give the index from where in between also we can start that, right? So peak first, peak last. So now once we see this, we should be able to go for create it and implement it, right? So we'll just go for C. By looking at this, we'll just go for start writing the code on our own. I'll just go for this, go for create a new class. I'll give it as linked list examples. I'll go for include a main method. We'll go for create a linked list. Linked list, variable name ll, new object. Okay. Linked list. Right. So now let me go for import that linked list. It is imported. For time being, let me just deal with an integer. Okay, so you can just go for deal with integer. So I'll mention it as like a specific type. So now what we'll do is we'll just go for use all the methods what we have seen, right? So ll dot add. So I'll send I have to send an integer. Since it is an integer, I'll give it as 11. Okay. And then I'll just print it as this linked list. Okay, before that I'll add at least one more number. Save, run, and you can see that it is going to print it like the array list only. Okay, so now we have other methods, right? So let me just go for see the methods what we have seen. Get is works something similar. Get first, return the first element in the list. ll dot get first. Similarly, linked list dot get last. Okay, let me just go for run it. You can see that we will be able to get first, get last. Again, we have seen like various other methods, right? Again, offer first means insert the specified element at the front of the list. So this for like again insertion. Peak, it will retrieve but does not remove. That is peak. Peak first, and we'll see this. And if I run this, you can see again it is returning 11. But now let us just try to find out the difference between this get first and peak first. What is the difference? Okay, so what I will do is I'll just have a int variable num equal to, I'll go for do it as ll dot get first. I'll just print that num. Okay, similarly and then I'll go for display it again. Okay, so you can see that like it's all going to perform in the similar way. Whatever the data type we have given, it will return an object of that. So whether it is peak first, or uh, the other method what we use, right? Get first, get last, all, like you can see this object. So that's where we need to understand, okay, it's going to return the object at that particular place, but it will not remove the elements. So that elements will be there. When I say get, it will not get it and delete it. So for doing that, like we have other options, right? Say this method poll retrieves and removes the head or the first element in the list. Poll first, poll last, and pop removes the element from the stack represented by the list. Whatever has been entered in the last is going to recently added will be removed first. That pop few more elements so that it will be comfortable, because insertion, removal, and all is happening, right? Okay, linked list dot. First we'll see the poll method. Okay, I'll just run it, and you can see that it is removing 10. Okay, so to have a better understanding, what I will do, I'll just go for display this linked list in between. Also, I'll display it after that poll operation. So you can see that this is the with like 11, 12, and 13. The moment when we do it, it is returning, but that object has been removed from that linked list. But whereas earlier we used to get the value, but the object is to remain inside that linked list itself. Pop. Okay. So linked list, what we have, it's a kind of a storage structure, and we can use it to implement queue as well as stack. Okay, so if you want to do a pop operation, we can just go for, instead of this poll, we'll do it as pop and run. See pop, whatever so this 12 has been removed and 13 is left out. Again, if you want to go for do the operation like push, you can do this push and pop, right? So the advantage of linked list in Java is dynamic size. As a vector, like is the linked list can grow, shrink dynamically, so you need not to worry about the setting the initial size and all. And efficient insertion and deletion operation, this is what the main requirement, where we are going to decide whether we want to go with linked list or ArrayList. ArrayList is better than linked list. The performance, the linked list is slower compared to the ArrayList. Okay, linked list is slower compared to the ArrayList. And memory overhead, linked list requires more memory than the ArrayList, because each element requires additional memory for link and the preceder and the successor element and all those things. So for the rest of the concept, right, so HashSet is the next collection what we have. So I'll not go for explain more in detail, because like if you have understood whatever we have seen so far in ArrayList and linked list, so you should be able to refer the API, and you should be able to understand the method description what has been given, and you should be able to use it. But I'll just go for briefly explain you what exactly this HashSet, what does that mean and what it does. Okay, go for open this, right? Again, it is something similar what we have seen in the previous two collections. Okay, so here we have the constructors, default constructor. Okay, and basically when we speak about this HashSet, it's a hashing concept, like how the data is going to be stored, right? So for which there are certain the initial capacity, whenever you create this, it will have a 16, that's the HashSet. Like if you go for create it with a default, it is going to create it for 16 element what we can give. And there's something called like load factor, based on which like it is going to have a increase decrease of the size and all, what is going to be taken care by this load factor. Default is 0.75. Even we can go for set that. So again, add, to add the element, clear. So this, when we see it in the broader view, it is going to work it in the same way. Like we'll insert data, we'll get the data. You can see add for insert data, clear for remove all data, clone for copying, contain for searching, is empty, right? Iterator to iterate through each and every element, remove the object, size to get the size, new class hash set demo. Okay, so we have to import this hash set. That's also available in java.util.hashset. So you can go for add. You can see that again it's going to print it in the same format of ArrayList only. Say new set dot, you can see all the method, right? So do remove, and we can mention, I'll just mention it as remove2. I'll go for save it, run it, and see. So we have 1 and 3 alone. I added like 1 2 3, and like we have removed it from that. And if I try to add a duplicate value, okay, save it, run it, proceed, still you can see that 1 and 3 only unique values are available. Linked list hash set. Okay, the data structure which will going to be used is linked list here, and the concept of this operation remains same. Only the backend, how it is going to be implemented, is going to have a difference. And compared to this hash set what we have seen in the previous, and this linked list hash set is like it's comparatively slower than the other things. Okay, and the next thing is and if you see this methods available, okay, only one method. Right, so now the question is like, okay, what is the advantage of this linked list hash set over the hash set what we have, right? So you can just go with, so if you see here, one is internal working, how it is going to work. Hash set internally uses a hash map for storing object, okay, and linked list hash set uses a linked list hash map internally. So basically like those are all the predefined data type. So more we understand like how it is going to be implemented in the data structure, basically it's like how data is going to be stored and retrieved. Okay, so what is important for us for time being is how to create an object, what are the methods available, and the most important is when to use it, right? So if you don't want to maintain the insertion order but want to store the unique objects, then go with hash set. So this is very important. Okay, so if you want to maintain the insertion order of an element, then you can use the linked list hash set. So which means it is going to maintain the insertion order as well as unique element. It will not go for duplicate the element, right? So here insertion order will not be retained, but here insertion order will be retained. And hash set given the time complexity for implementation, right? So O of 1, and then here also, here you can see that operation is O of 1, but performance wise, see this time complexity is same, but the performance wise the hash set is better when compared to the linked list hash set or tree set. Okay, so that is what. So which means set is the basic concept. The same set operation we can implement using three things. One is hash set, linked list hash set, another one is tree set. Tree set means it is going to use a tree data structure to store those unique values. Able to understand? Okay, so that's how we can go for create the tree set also. right? So that's why they have compared over HashSet, LinkedList HashSet, and TreeSet, all three. So if you now, the most important is when to use it. If you want to sort the elements according to some comparator, okay, then use a TreeSet. So the conclusion is, when you want to go for HashSet, if you don't want to maintain the order of insertion, go with HashSet. It is much better implementation, or it's faster than linked list HashSet and TreeSet. And if you want to maintain the order of insertion, go with linked list HashSet. If you want to don't want to maintain the order, but if you want to store it in a sorted order, then go with TreeSet. HashMap. Okay, basically it's a dictionary implementation what we have seen in Python, which we can do it again. TreeMap, so it will use hash for storing the key value pair, and it will have the tree data structure to store the key value pair and iterating through this map. HashMap versus TreeMap and linked list HashMap. Okay, create new class HashMap example. Need to import that java.util.hashmap, and you can see that key data type, value data type what we have given, and once we give that, the object is going to be created, and then we can just go for add the values. I'll just give it as map dot add, so where we have to give two values, right? So I'll give it as 11. Okay, and I'll just give the same thing. Put method, add method is not there. We have put method. Okay, we'll just see what all the methods we have. We have clear, clone, compute, and you can see get method. We can pass a key, we'll get a value of that. And for each, we can use for each method, and we can also see key set, sorry, put. Yeah, this is the method put. Again, we can combine by using the put all method is also available, and we have seen this get method also, right? So this, what I will do is 11. Okay, map dot get, I'll give it as 11, save it, run it, and you can see that we can get that key value like this. Okay, right? Same thing can be implemented using a HashMap, TreeMap. Okay, so when we speak about a TreeMap, we'll go with TreeMap object creation, and we'll go for use same method, put and get method what we have seen. But the thing is, how it is going to be implemented, what data structure or storage structure it is going to use is going to differ. Okay, so if you see here, HashMap, linked HashMap, and TreeMap. So the time complexity is O of 1, O of 1, O of 1, because the concept of map itself is like to access the data with order of 1, right? Iterator will be random, so which means the order in which it is stored will not be inserted, will not be stored in HashMap. It's the same thing. If you want to have a key value pair, but if you want to retain the order, then go with linked list HashMap. And if you want it in a sorted order, then go with TreeMap. As simple as that. So whenever we speak about hash, order will not be stored, it will be random. Linked hash, so it will be order will be stored, and TreeMap, it will be get sorted automatically. So now what we are going to do is we are going to create a user defined array list. So if you want to create a user defined array list, So you can see that array list in the data type will give the user defined. User defined means like the class which you are going to create. Say for example it is student. Okay, so you can see that student class has been created. This is the attributes and this is a constructor. Again you can go for having getter, setter. Now along with that, what you need to do is you need to override toString method, and you can just mention whatever the way you need to print that object details, you can return that as a string. That is one thing. Okay, and along with that the equals method. See, when we speak about a equals method, this is how one object is going to compare with the another when we are going to use this, like when we are going to compare. So we have seen that last time, right? So when we try to use the equal to symbol, it will go for compare the reference, right? So whatever the object we have, so you will receive it as an object only, generic object. So that we need to typecast. How to typecast? So if you want to typecast, you need to use this in the parenthesis, give the user defined data type and then assign it to the variable, and then you can define the condition how you want to compare. Roll number should be equal to roll number, that is this dot roll number equal to that new object what we have, that yes dot roll number. If you directly take this obj and try to compare, it will not compare. You will not be able to compare because object doesn't have the attribute called roll number. So that's why this typecasting is most important. If you don't do that, you will not be able to get this, or you will get an error for not having an attribute. Okay, and then again the name should be equal to the name. So when you want to compare name, again say they want to ignore the case and compare, because maybe the in one object the name could be uppercase, lowercase, may vary, or it could be block or the title case, or capital completely capitalized. So then they are going to give it as equals ignore case, and then they are comparing. So that they in this equal ignore case is already defined in a string method. Create one more object. I'll just run this for some. So this is how every time from now onwards, please, whatever the user defined data type you are going to write, please ensure you are going to override toString as well as equals method. Okay, go for show you. If say okay, they are adding it to array list, right? So I'll just take this array list dot get of 0, so we'll get a student. Okay, object, so that is equal to array list dot get of 2. So I'll try to do one more thing. I'll create another object. See, the moment when we use new, it is going to create another object. Okay, so since it is array list, we can have duplicate, like whatever. So we are going to have one more 3, and this is the value what we are storing and creating object, right? So same thing, I'll try to compare between this object at second index and object at third index. Object at second index, object at third index. Run it, proceed. So it is going to give us wrong, because when we do this equal to anytime, it is going to compare the reference, right? So what is the right way of doing? So the right way of doing is dot equals method dot so we have already defined it here, right? This equals this other object. Okay, and if I go for run this, proceed, and you can see it as true. So this is how you can compare two objects of user defined just by overriding the equals method.